So ladies and gentlemen, welcome to our mathematics class, and in this particular mathematics I'm going to look at 2022-2023 final examination for math 1100. So basically in mathematics the concepts are almost the same both for math 1100 and math 1120. So what's important is for you to just make sure that you know the concepts and apply them. So I'll just look at two questions in this particular paper, then in my part 2 I'll look at other questions. So I'll go part by part. So let's quickly look at question 1. So question 1 is having three sections. There is A, B, and C. So that's what question 1 has, and each question has certain marks which have been given. Like if you observe, for 1 it is 2 marks, and then for 2 it is 3 marks. Then the other one, you will find that this 6 marks is for the first one, and this 2 marks is for the other one. So just same applies to C. So let's quickly look at these questions individually and see how best you can approach them. Remember that this is the exam, so you need to make sure that your work is clearly illustrated, and you need to make sure that you are able to show your work accordingly. So you're going to say solution. That's what I'll simply state, and then after that I'll read out the question. So the question is, use the laws of algebra of sets to simplify the following expression involving sets. So there is a tutorial video which I've already done on algebraic laws of sets. So for those who haven't gone through, please, you can watch it after this class. So I'll start with the first one. The first one is A minus open bracket B minus A close bracket. So according to the rules of algebraic, you need to understand that an expression which is written as A minus B is the same as A intersection B complement. Same applies with an expression which is, let's say, A minus, let's say, B intersection C is the same as A intersection open bracket B intersection C complement. So this is the one of the rules that you are supposed to take note of as you try to solve these questions. So I'm going to use this rule to work out this question. So what I'm going to do right now is that I'm going to change this minus to intersection, so it will be A intersection, and then I'll say B minus A, and then I'll say close bracket complement. So I have put a complement this side because I've changed a minus to an intersection. Then I'll do the same thing with the inside. So I'll say A intersection open bracket B. What is negative there, a minus, will change into intersection, and A will surely have a complement, and then that complement will be maintained like that. So after I do that, the next thing, this A outside, it's independent, so it will be A intersection. I'm going to multiply this complement by everything there. So this will be B times complement, it's B complement. Intersection times complement, it becomes union. Remember, intersection times complement, it becomes union. Then A complement times complement is simply what? Simply A. Once I do that, the next thing is for me to use the distributive law. the next thing that I have to do is now to use what? The distributive law. So here I'm going to pair A with B complement. So I'm going to say A. Remember, I'm going to take this intersection, and then I say B complement, open bracket, this union will come there, then open bracket, I'll get that A and that one, so it will be A intersection A, and then I'll put them like that. Once I do that, I'll be able to check out and see my solution. So I need to look at what I've been said. So use the algebraic laws of sets to simplify the following expression involving sets. Okay, so when you look at this particular question, when you work out this guy will simply be open brackets A intersection B complement, and then close brackets union. You know that the A intersection A, it's simply what? It's simply A, so it will simply be what? A. Now here you have A intersection B complement union A intersection B complement union A. So if you look at this question, I can simply illustrate it using the Venn diagram. For me to simplify there, just by looking for someone who has done mathematics much, they will be able to tell you that, okay, here the answer is what? The answer is A. But for you who hasn't done much mathematics, you can bring in the Venn diagram for you to do what? To work it out. So we are going to say, let's say this is set A. We assume they are intersecting sets, and then this is what? This is set B, and then you have the universal sets there. So this is set A, this is what? Set B. For those who haven't done much mathematics, you can use this Venn diagram. So B complement, it's simply anything outside B. B complement is simply anything which is what? Outside B. So this is what we are looking for. Now if you look at A, set A is simply this particular set. Set A is simply this particular set. Now B complement intersection A is simply A only. So what you're going to discover is that if this is your A and this is your B, this is your A, this is your B, A intersection B complement, the answer is just the A only, such that your answer is just finding itself within this particular area. So that's where your answer is. So this is what? A intersection what? B complement. A intersection B complement. Now what we need to understand is that we have been told that yes, after we have found A intersection B complement, we also need to unify this expression. We need to find the union of this and the A. So if you bring it up, you're going to have A is there, B is there, and then this is your universal set. This is your universal set. This is A, this is B. So this guy, this A intersection B complement, this shaded region, when you unify it with A, what are you going to have? You're simply going to have set A. So you're just going to have set what? Set A. So the final answer here is just what? A. So this was the final answer for this particular question. So this one is now open bracket A intersection B complement close bracket union A. So this is how easily that question would have been done. Do we have any questions, ladies and gentlemen, at this particular point? Any question? Feel free to ask. Any question? Okay, it's like we don't have questions. Let's move on and look at question number 2. So the second one on this same question is this one. So this one is a little bit big as compared to the other one. So we have block bracket, open, A intersection B, close bracket, complement, union, open, A minus B, close, and then we have block bracket, complement. So this is what we have. So basically, when you are in an exam and you're trying to work out these questions, you need to be so careful and accurate. You need to be so careful and accurate because any mistake might cost you. So let's quickly move on and look at what we can do with this question. The first thing that we are going to do, we are going to multiply this complement here by everything that is inside. So if we multiply complement times that complement there, this will be A intersection B, like that, because complement times the complement, it will give you a what? It will give you a 1, which is just the same as that. Then union will become what? Intersection. And then A minus B, you multiply it by a complement, it will surely be what? A minus B complement, like that. Then from there, you can simply say A intersection B, open bracket, intersection. What is inside there, you can change it. So this will be A intersection B complement, and then E complement outside there. After you reach that particular point, you can multiply this complement by everything inside. So this will be A intersection B open bracket intersection open bracket. This times that, it will be A complement union, because intersection times complement, it's union, and then that will simply be B. So if you look at A complement union B, A complement union B, what are you going to have? So A complement union B is simply B. A complement union B is simply going to be B with the outside. Yeah, it's going to be B with the outside part. Now you have whatever you have, you intersect it with that one. Now if you look at how it is, this A intersection B is more like the small sets. Since we are intersecting, you're going to pick the small set. So A intersection B is more like a small set. So your answer will simply be A intersection what? B. That's the final answer. So I'll give you a task of you using the Venn diagram for you to reach at that particular point. So this is how easily you can solve this question. Do we have any question there? Any question? Any question on this particular part? Are people around? Are people?
Yes, we are around. So.
Okay, all right. So is it clear, Frederick? Is it clear? Frederick, is it clear?
Sir, it is clear on some other parts, but I'm having some confusions.
Where?
So I'll try to ask you. Let me just work them, so that I can be able to ask you properly.
Okay, all right, no problem on that.
Yes. Okay. For this one I can ask, sir. For this one I can ask.
Yes.
There on that part where it is written A intersection B intersection A complement union B.
Yes.
Now that you've said A complement union B is the same as B.
No.
So is it okay for us to use the associative law
No.
and write it as A part?
No. I haven't said A complement union B is B. I've said A complement union B is B with the outside. A complement union B, it is B with the outside. So if you have this as your A and this as your B, okay, let me try to illustrate it using the Venn diagram. So this is your A, this is your B. So A complement union B, it is B with the outside, meaning it is B like that with the outside like that, without including A. So this is A complement union B like that. It's not B, but B with the outside. Then when you pick A intersection B, let me just sketch it. So you have that and that one there. Then this is your universal set. This is your A, this is your B. Then if you are looking for A intersection B, A intersection B is this particular this particular set. So this is A complement union B and this is A intersection B. Then you have been asked that this one and that one should be what? Intersected. So if you look at the intersection for this A, this one I'll put it as 1 and 2. If you look at the intersection between this one and that one, the answer is this one. The intersection between this one and that one, the only part they are common, it is that point here, which is simply that point. That's why we have said D, it is A intersection B. Is that clear, Freddy? Are you around?
Yes, I'm around and I'm listening.
Is it clear?
Yes, it has been made clear.
Okay, that's good. So let's move on. So this was the solution for the first part. So let's quickly look at the other parts. So we have this question on functions. So for this part, I'll specifically have a class on this, but for now, I'll simply work on it the way it is. So please make sure that you follow up. So here we have been told that the equation f of x squared plus 8x minus 1 is equal to 0. So you have the equation, which is 4x squared plus 8x minus 1 should be equal to what? 0. So what you are going to do is that you can put this as your A, this as your B, and this as your C. Now, before. That's why this question is having how many marks? 6. This part is having how many marks? 6. It's not just 6 for decoration, because there is a little bit of thinking. So you make this as A, this as your B, this as your C. Then your first thing is to find what we call the sum. Your first thing is to find what we call the sum. So to find the sum, what you're going to say is the sum is equal to alpha plus C beta. The same guys we have been given, alpha and beta. So the sum will be alpha plus beta. So the sum according to the formula, it will be negative B over A. This is the formula for the sum. Now, after you find that, you're going to say alpha plus C beta is simply equal to, what is your A? Your A is 4 and your B is 8. So it's going to be negative 8 over T over 4. So alpha plus beta is simply equal to negative 2. That should be your first step. Now, your second step is to look for the product. Yes, you have found the sum, but you now need to look for the product. For the product, you shall say product is simply equal to alpha beta. Alpha beta is equal to, the formula is C over T over A. Then alpha beta is simply equal to, what is your C? It's negative 1. So you're going to put negative 1. What is your A? Your A is what? 4. So this is your sum and this is your product. Now, what you have done here has not answered this one and has not answered that one, but it has carried the marks. Now, once we are done with this, we now need to go to the questions. Let's quickly go to the question. So I'll write solution. So remember, alpha plus beta we have found to be negative 2. And we know the product alpha beta we have found to be negative 1 over 4. So our next step is now to work out this part. So let's quickly work out that part and see how you can easily answer it. So you're going to say you're going to get the first one, which is this one. This one, that one, no, this one here. So I'll put it as my A. So this one is alpha cubed beta plus alpha beta squared cubed. So alpha cubed plus beta, alpha cubed beta plus alpha beta cubed can be worked out in the following way. This is what you're going to do. You're going to say this, you can factorize alpha and beta. You can factorize alpha and beta. So you say alpha beta open brackets, when you factorize there, this will be alpha squared beta alpha squared. We know beta will not be part of the solution there, so let me erase that. And then that one will simply be plus beta squared. So this is what you are going to have when you factorize that. Now, this which we have here has its way of finding it. This which you have here has its way of finding it. Let's quickly find a way of finding it. Now, why are we finding a way of finding this one? The reason is that we only have that particular part. Let me highlight it for you to be able to see. We only have this part here. We don't have alpha squared. We don't have beta squared. We don't have alpha squared, and we don't have what? Beta squared. So because we do not have those stuffs in this guy, we need to find a way of having them. So let's quickly find a way of having those guys I have highlighted. So this guy here I am shading in green has its own way of being found. This guy here I'm shading in green has its own way of what? Finding it. So I'm going to write down the way of finding it. So let me quickly write it down. So this way, this one here, can be found as follows. We can simply say open bracket alpha plus beta squared is equal to, so when you expand this one, this will be open bracket alpha plus beta close bracket open bracket alpha plus beta close bracket. Then you are going to say alpha, will multiply it by everything, so it will be open bracket alpha plus beta close bracket plus beta open bracket alpha plus beta close bracket. Then you are going to say alpha times alpha is alpha squared, alpha times beta it's alpha beta, it's alpha beta, then beta times alpha is alpha beta, beta times beta it is beta squared. Remember, this side it is alpha beta squared, this side is also alpha plus beta squared. These guys can be written as alpha plus beta squared is simply equal to alpha squared plus 2 alpha beta, because they are like terms, plus beta squared. After you do that, you are going to make alpha squared plus beta squared as a subject of formula. So you are going to have alpha plus beta squared. This guy will go to the other side, so it's going to be negative 2 alpha beta is equal to alpha squared plus beta squared. So from that, everyone is able to understand that we have simply found what we have been looking for. So this alpha squared beta, which is in green, has now been found. And we are able to see that we now have the guys in yellow which we were also looking for. Simple. So this is what we were looking for. We are looking for anything that is related to yellow. And we had something in green. We derived it. the way I've tried it, and we have reached there. So after reaching there, you can now work on such that where there is green, you are going to replace with what is in yellow. Where there is green, you are going to replace with what is in yellow. So you are going to say alpha cubed, alpha cubed, alpha cubed beta plus alpha beta cubed plus alpha beta cubed is equal to alpha beta cubed is equal to, you are going to put what we have there. The first thing we have, it is what? It is alpha beta. So we'll put alpha beta and then open bracket, what is in yellow will replace what is in green. What is in yellow will replace what is in green. So in short, what we are going to have now is open bracket alpha, open bracket alpha plus beta squared plus beta squared minus 2 alpha beta, and then you put what? Block brackets. Ladies and gentlemen, at this particular point, do we have anyone with a question? Anyone with a question before I move on? Okay, all right. With that being done, what we can now do is we're going to say is equal to, where there is alpha beta, we are going to put alpha beta, we are going to put -1/4. So you say -1/4. Okay, you put -1/4, and then where there is alpha plus beta, where there is alpha plus beta, you are going to put what? -2, and then squared, you say -2, where there is alpha beta, you're going to put -1/4, and then like that. With that being done, you can simply say -1/4 dot what is inside -2 squared is simply 4, and then you have plus, because negative times negative, it's positive, then 2 there, 1, 2 there, 2, then 1/2. After you do that, you can find the summation of the two. So if you work out everything there, this guy will simply give you -1/4 multiplied by what is inside there. Common denominator is 2, and then there it's over 1, 1 into 2, it's 2, 2 times 4, it's 8, 8 plus 1, it's 9. So you're going to have that. Then when you multiply, your final answer will just be -9/8. So you have found the first part, which is that part there. Now, after you find that part there, you have another task. Another task that you have at this particular moment is to go for B. So when you go for B, this is how you're going to do it. By the way, this whole thing we have done here, we have just simply found the sum of that expression there. So this is acting as the sum, and that is acting as the product. So when you do this, you have found this one. Now you need to look for the other one. You need to look for the other one. So let's quickly look for the other one. All right, solution. So the other one is, I can put it as b from I. The other one is alpha cubed beta open bracket times alpha and then beta cubed and then brackets. So if you look at this, we can simply multiply this thing times that. So we have alpha cubed beta times alpha beta cubed. So if you multiply that by that, you're going to have something like alpha to the power 4 dot beta to the power 4. Alpha to the power 4 dot beta to the power 4. Then that one, which is alpha to the power 4 beta to the power 4, can be worked on by simply saying open bracket alpha beta to the power to the power 4. Now remember from what we worked on. What we worked on from the very beginning, we found that alpha beta is simply equal to what? Negative 1/4. That's what we found. So we are going to replace where there is alpha beta, we are going to replace it with negative 1/4 because we already have it. So let's quickly work on it and see how best we can go about it. Okay, I don't know if there are any questions so far. Any questions? Okay, I'm sure people are following. So from there, we are going to put negative 1/4 down on where alpha beta is to the power 4. And then if you say negative 1/4 to the power 4, the answer will simply be 1/256. 1/256. So you can now conclude, therefore, the sum, which is this one, alpha cubed beta plus alpha beta cubed, is simply equal to what we found, which was negative 9/8, and the product which is simply alpha cubed beta times alpha beta cubed is simply equal to 1/256. 1/256. So when you find those two figures, you can now go onto the equation. So from the equation, we can simply work on it as solution. I hope people are following. So there, the normal equation we had was 4x squared plus 8x minus 1 is equal to 0. So from there now, remember the equation need to be in this particular form now, which is x squared minus open bracket alpha plus beta, and then x, and then we have plus alpha beta is equal to 0. I'm going to explain more in the class which I will specifically have for this topic. Then from here, we are just going to replace what we found as the sum. So what we found was that this will be x squared minus what was on alpha beta according to the solvings was negative 9 over 8 close bracket, you say x, and then what was the product was plus 1 over 256 is equal to what? 0. So when you work out that, this will simply be x squared plus 9 over 8x plus 1 over 256 is equal to 0. So then you have answered this particular question, which is 2. That's it. That's how easily you can work out that question. That's how easily you can work out that particular question. Unless if there is any question before I move on. Do we have any question, ladies and gentlemen? So, ladies and gentlemen, for mathematics, you need to practice. And where you are not clear, you need to make sure that you ask. So, let's quickly look at C. So, I'll write as my solution once again. So, the question is, given that square root 2 is irrational, show that alpha or square root 2 plus 3 is irrational. If you check part 1 of irrational numbers, I have answered this question. So for those who are going to have time, go and check part 1. So I'm going to start and write it as follows. So we have been given square root 2 plus 3. Okay? So this is what you are going to say. You're going to say, by contradiction, you write that, let square root 2 plus 3 be rational. Such that this square root 2 plus 3 will be equal to P over Q. Because when something is rational, then this has to be in the form of P over Q, where Q is not supposed to be equal to what? 0. Where P and Q, if you want P or Q, should not be equal to what? 0. Then after that, then you are now going to say square root 2 plus 3 is equal to P over Q. 3 will go to the other side. 3 will go now to the other side. So you are going to have square root 2 is equal to P P over Q minus what? Minus 3. After we do that, your next step is to solve these guys as math. So you're going to say square root 2 is equal to common denominator is Q. Q into Q, it's what? It's 1. 1 times P, it's P. This is over 1. 1 into Q, it is Q. Q times negative 3, it's negative 3Q. Now, since you have to write the following, since square root 2 is irrational, okay, since square root 2 is irrational, that is coming from the statement here. And if you look at P minus 3Q is what? Is rational. Since square root 2 is irrational, but P minus 3Q over Q is a fraction, so it's rational. So P minus 3Q over Q is rational. Is rational. You write that. Then you say rational, okay, rational cannot be equal to irrational. Rational cannot be equal to what? Irrational. In short, an irrational number cannot be equal to a rational number. So this normally contradicts our assumption. So you're going to say this contradicts our assumption that square root 2 plus 3 is rational. Therefore, square root 2 plus 3 is irrational. So write square root 2 plus 3 is irrational. That's how you solve. Each of these statements I've made are very important. The marker will not just go direct to the down guy and mark. No, they'll simply also check how you were moving. So that's how easily you can solve question 1C1. With that in mind, I'll quickly go and look at question C2. Question C2. So I'll write my solution. So in this particular one, we have been given 0.0810 bar. Okay. And then they want us to put it into the form P over Q. But before I talk about this question, is there anyone with a question, anyone with a problem on the previous one? Anyone with a problem? Nelson, do you have a problem?
No, it's very clear.
It's very clear. Okay. Who else? Malama, Esther, do you have a question? Esther? Okay, maybe. Frederick, Do you have any question?
No, sir.
Okay, all right, let's move on and check out the next one. So this one, you're going to say this one is very easy. You can just do it fast. So you're just going to say let 0.0810 be equal to x, or you can say let x be equal to 0.01. I think that's the term you guys are used with. So let me just use what you are used with and the words I was using in part 1 of rational numbers. So go and check rational numbers for this question. Go and check on rational numbers. I have solved it. So we're going to say let x be equal to 0.0810 bar. Then you are going to count the number of decimal points which don't have a bar. So you only have a 0, which is 1. So you're going to say 10x is equal to, that will simply be 0.810 bar. Then, okay, then you're going to count everything after the decimal point. You're going to count everything after the decimal point. So everything after the decimal point, there are 1, 2, 3, 4. So you're going to put 4 zeros like that, is equal to, and this will simply be 810.810 bar. Then after you do that, your next step is now to do what? Your next step is now to subtract what I am going to highlight. So this is what you are going to subtract. These are the two guys you are going to subtract. You forget about the first one because you have now moved 3 steps, and focus on only the the last two guys. I think this is also in part 1 of the class. I explained on irrational numbers, and then also part 2 there is such a question of this type. So please go and check out those 2 parts I've explained. I'll send the links, and please make sure that you check them out. So from there you get this one and that one. So you're going to say 10,000 x, 10,000 x is equal to, please there is x there, 10,000 x is equal to 810.810 bar. You subtract the 10x there, you're going to put 10x there is equal to, which was what, 0.810 bar. Then you subtract like that. So when you subtract, this is what you are going to simply have. So 10,000 minus 10, the answer is simply what? 10,000 minus 10, it's going to be 9,990 x is equal to, you're going to subtract that, the part which will just simply be what? 80, 10. Then from there you divide throughout. You're going to divide throughout by 910, 990 x. You divide throughout again 9990, not with x, just the number there. Okay, so when you do that, you simply know that this one and that one will go. So in this case, your x will simply be equal to 8/10 over 9990. So make sure that you leave your answer in simple, you leave your answer in the simplest way. So you don't have a calculator, so that 0 and that 0 will go. So you're going to have x is equal to 81 over 999. Then after that, you are going to divide again both parts by 9. So x will simply be equal to 9 into 81 is simply 9. 9 into 9999 is simply 111. So this is your this is your answer. Actually, this can also go further, and you can simply have that guy can go further, and you can simply have 3 over 37. So make sure that your answer is not left in this part, but it has to be left in the lowest or simplest form. So guys, this was the solution for question 1. This was the solution for question 1. I don't know if there is any question so far. And remember that we have question 2. So this will be question 2. So for question 2, what we'll do is that I will not solve it now because of time. Instead, I'll solve it in the next class tomorrow. So tomorrow, same time, we are going to have a class where I'll just specifically solve this question. Either I'll solve this question or I'll go and solve question 1.